Welcome to this high-intensity review session. Yasser, Akram, Mohammed, Abdul Rahman, Ahmed, Ziad, and Abdullah. We have 9 lectures to synthesize, and we're going to build that framework right now. We'll track our progress using this mental map, branching from the core of interactive content. Education has historically relied on a one-to-many delivery model, where students function as passive consumers of information, with little opportunity for structural pushback. Modern interactive design moves the learner into the role of an active decision-maker, giving them direct control over the pace and trajectory of their learning. We need to be precise about what interactivity actually entails. Yasser, if a student simply clicks play or pause on a video, does that qualify as true cognitive interaction? Correct. That is operational interaction. True cognitive interactivity requires the learner to solve a problem or make a choice that fundamentally branches the learning path. Effective, interactive design engineers digital environments that demand continuous cognitive effort from the learner. Building those environments requires the theoretical engines from Lecture 2, behaviorism, constructivism, and cognitivism. Behaviorism, defined by B.F. Skinner, provides the basis for immediate feedback and reinforcement loops, ensuring learners receive instant validation for their responses. In multimedia design, Richard Mayer's cognitive theory provides the primary constraint. Mayer posits that the brain processes information through 2 separate limited channels, one for visual intake and one for auditory intake. Exceeding the capacity of these channels leads to cognitive overload, a state where the brain can no longer effectively process or store incoming information. This creates a strict design rule. Akram, which Mayer principle warns against displaying a block of text while reading it aloud verbatim? The redundancy effect. When the visual and auditory channels are forced to process identical text simultaneously, you create a bottleneck that degrades learning. Respecting these cognitive limits allows us to design interfaces that facilitate deep understanding rather than simple data consumption. Lecture 3 moves from theory to systematic application using the ADDIE model: analysis, design, development, implementation, and evaluation. There is a misconception here. Mohammed, does evaluation only happen at the end of the project? No, formative evaluation is a continuous requirement. You evaluate throughout the analysis and design phases to catch structural flaws before the product reaches the learner. In Lecture 4, we apply the ADDIE framework to create interactive video, moving beyond linear timelines. By utilizing hotspots and branching narratives, we allow the user specific choices to dictate the sequence of the lecture. Advanced designs integrate 3D objects directly into the video. The lecture pauses, allowing the learner to rotate and examine complex models from any angle. Abdul Rahman, to guarantee comprehension before proceeding, would you use a passive pause or a forced quiz? A forced in-video quiz leverages the testing effect. Mandatory interaction points compel active recall, ensuring the learner is prepared for the next block of information. High-quality interactive video removes the spectator option, forcing the viewer to become an active participant. Lecture 5 pushes active participation into digital educational games, complex systems that require real-time adaptability to a player's skill level. The core gamification loop presents a specific stimulus that requires a deliberate, positive response from the learner to advance. Ahmed, under a constructivist lens, what yields higher cognitive return? Playing a game or designing it? Designing the game is the superior cognitive exercise. When programming logic and rules, students must first build precise mental models of the subject matter. Building these systems without deep software engineering skills is the focus of Lecture 6. Authoring tools provide the necessary interface to build interactivity without writing raw code. Ziad, regarding the workflow, does the process begin by importing media files or by selecting the structural template? The template comes first. The 3-step authoring workflow consists of template selection, media integration, and finally, publishing. These tools allow educators to focus on pedagogical strategy rather than technical syntax. Lectures 7 and 8 explore how visual design and UX direct and sustain learner attention. Poorly organized visuals create cognitive friction. Clean, intentional design lowers the entry barrier, allowing the brain to focus entirely on the learning objectives. Abdallah, does high-quality UX design increase overall project costs, or does it improve the long-term return on investment? It improves ROI. Quality design reduces the need for expensive future corrections and increases the effectiveness of the training. Lecture 9 covers intellectual property. Designers must master the legal frameworks governing their digital work. Copyright law protects the tangible, fixed expression of a work. It does not extend to the underlying idea. Designers must balance the protection of their own creations with the strategic use of open educational resources to build courses efficiently. Yasser, if you have a theoretical idea for an interactive video that hasn't been built yet, is that idea protected by copyright? No. Copyright protects execution, not abstract concepts. Navigating these rules ethically is a requirement for professional instructional design. We have now mapped the entire journey across 9 interconnected lectures. We have moved from cognitive theory and the ADDIE blueprint into the practical application of video, games, UX, and IP law. Yasser, Akram, Mohammed, Abdul Rahman, Ahmed, Ziad, and Abdullah, you are here to develop a precise engineering intuition for the human learning process. You now have the tools to turn passive spectators into active learners. Best of luck on the exam.